This is VBS Office, and today I'm going to show you how to make a Minecraft game in Python using the Ursina engine. Let's get started. So the first thing that we want to do is get all the assets. You can find it in a zip folder, but I already have it, so I'm going to go get them. So these are all the assets. So we'll go open up our project folder and drop them in. Okay. And the next thing we want to do is install Ursina. So you could go pip install Ursina. I already installed it, so mine's already done, but for you it might take some time. And the next thing that we need to do is, of course, make our Python file. So we're going to call ours game.py. And before we actually get started, I'm going to show you what the final game is going to look like. So to do this, okay. This isn't actually too complicated with the library that we're using. Alright, so I'm going to make sure that you can hear the sounds. Yep. But here we are. We have the red dot in the middle as our cursor. We can jump. And we can place blocks. As you can hear, there's a little sound when you break and make blocks. And we could do all sorts of stuff. So you could make bricks, stone, and dirt. You can go dirt and grass. There you go. And if we want to make something that we want to save in our archives so that we can access later or something, let's make something. Let's export this. To do this, we can press the E button and it will export. It just chose a random number, which is 40. So then we can quit the game because we don't need that. But we could go ls, find it, there you go, world of 40. And to run it, do the exact same command that you did, but this time pass in world 40.json. There we go. So now we could do the same stuff to the thing, like keep on going. We can also get rid of this. Oops. Yeah, so this is the game that you're doing. You also have little stats like the FPS corner and the counter. In the corner. Yeah. So let's make this. So we have our assets. Our assets consist of the texture UV maps, so the arm, and our OBJ files, which will give it the shape, which is this, our OBJ files, and then our sound effects, which is block break and block make.mp3, and then we have, once again, our block OBJ to give it its shape, and then we have the UV maps. So, well, this is just a PNG image. This is not a UV map. This is what's going to show in the inventory, or the hotbar, or whatever you want to call it. And then this is the UV map for the brick block, which is going to actually wrap around the block to give it the texture. And then we have the dirt that'll show in the inventory. Hotbar, whatever. I use inventory. And then grass, and then the grass UV map, and then the inventory with the 4 slots, because we only have 4 blocks. And then we have our sky, and then we have the stone, which goes in the inventory, and we have the UV map. So this is all that we need. So we can start making the game. First, we're going to load Ursina by going from Ursina import star. And we also want a library in Ursina called first person controller, which is going to let us move around like it's a Minecraft game. So we'll go from Ursina .prefabs.first person controller import first person controller. And then for the export, we're going to need 2 libraries. Actually, no, 3. We're gonna need Json to export it. So Json. And then we're also gonna need random range to get us do a random number for the world number. So we'll go from random import rand range. Okay? And then we're going to need the sys, so we can go import sys. This is going to let us read the argument that was passed in, which is the world name. Okay, so to create it, it's as simple as going app equals Ursina. Okay, and then let's load in our textures. So let's start with grass texture. Load texture. Let's go assets, grass, block. So it's the name of our UV map. So we'll do this for all 6 of our textures. Okay, and this time I'll go stone and brick and dirt and sky and hand, which we're going to call arm. Okay, so then we just have to do the same thing to the files. Stone, brick, dirt, and sky. And arm. Which is, oh wait, no. This is not the name because sky's not a block. Sky is a skybox, so like a skybox. And then here, for the arm, it is called arm texture. So arm texture. Okay. So now we want to load our audio files for breaking blocks and making blocks. I'm going to call this block break equals audio. And for the first argument, this is going to be the path, which is assets block break .mp3. And then we also need make. Actually, no, I forgot some arguments. We need to pass in loop equals false and autoplay equals false. Okay, so now we have those sound effects. Oh, that drives me crazy. And then we also need what texture you selected using the number pad. So we'll go texture picked is equal to 1, which is the grass, which is what's the default. And then we're going to need the voxels, which will store all the voxels, or blocks, as you might call it, in a list, or array. This is so that we can use it for exporting, which will store that array in a file. Okay, so now we're going to need one more thing, which is a general function called index in list. This is so that we can get the index in the list. We're going to pass in a list and index. Actually, I made a mistake with this. This is checking if an index is actually in the list. Okay, and then we'll go return index, okay, less than the length of a list. Index. Okay, so now we have the function. So now we're going to need one more that will check all the time for key input, which is called input. This is a built-in function in Ursina. So, no, sorry. Update This is going to run every frame. And then one of the arrays that we can define or use is the held keys, which can detect what keys you're holding. So let's start by making a global variable, well, making texture picked global so you can access it. And then we're going to need if held keys, this is for the hand by the way, is equal to left mouse, or held keys is equal to right mouse. Then we'll go hand.active. This will all make sense when we make our hand class. And hand else, we can go else hand, oh I forgot, hand.passive. Okay. So as you can see, we're getting a warning, which is hand is not defined. We'll define it later. Then the next thing they're going to need to do is detect for each key, which is going to be for the inventory slot. So we could go if held keys is equal to 1, and we'll set the texture picked variable, which is now global, to 1. And we can repeat this, except using an elif statement. So we'll go elif held keys is equal to 2. Texture picked is equal to 2. And we can keep going for 3 and 4. 3, 4. Okay. Let's see. So now we're going to do one of our main classes, which is voxel or block, but I'm going to call it voxel. So let's make a class, voxel, and the bracket is actually not a parameter. This is what the class will extend. And we're going to extend it from Ursina button, so we can go button. This means that we can press it and add input to it. So now we need to go define as a function init, and we actually don't need this crap, so we'll get rid of it. And we also don't need this text radius and kwargs, so we'll take that out. So let's set the parent to scene, which is going to be the global scene of Ursina, and the position equal to position. Actually, I forgot to set some stuff. This is where we're going to pass in our parameters for voxel. So position, and the default is going to be 0, 0, 0. And we're also going to need to pass in the texture, and the texture is going to be default to grass texture. So now I have the position model is equal to the block, which we actually don't need the extension because it'll auto search for us, but this is our block obj file, which, as I said, will give it its shape. So you have the block. Now we need to set the origin y. So origin y is equal to origin y is equal to, what is it, 0.5. So we could go 0.5. Then the next thing that we're going to need is the texture, which is of course the texture that's passed in. So we go texture equals texture. And then the other thing we're going to need is the color, and it's going to be white, but it has a custom texture on it, so it doesn't really matter. But it will affect what the block will look like because it won't have a tint of gray or white or red or something. Then we can go highlight color, and we want this to be a little faint color because we have a texture wrapped on it, and if you have a heavy color, it'll look extremely ugly. So we'll go highlight color equals color, dot color. Instead of going dot white, we can do RGBA. So we could go 0, 0, 0.92. Okay, and then we can set the scale of the block to 0.5. This will match our OBJ file. And then the last thing we're going to need is the local texture number. This is going to be used for exporting, but this is how we're going to keep track of what texture is picked. So, I have to, yep, get rid of this, and turtle. This is stuff that auto-imported, so we don't need that. But, it always wants to correct stuff. Let's go local texture number is equal to the texture picked, which is what you used on your keyboard. Okay, so now we have everything. The last thing you need to do is actually append this voxel to the list, which is voxels. So we'll go voxels dot append, and we'll just make a JSON object, which is a dictionary in Python. But we can go x, and we could go self, which is the block itself, dot position dot x, and then y, self dot position dot y, and z, which is self dot position dot z. Now normally for the phaser stuff you wouldn't do z. That's because that's 2D, not 3D, and this is 3D. Now we need to pass in the texture, which is the texture key. So which is self dot local texture texture picked. Not that, because we haven't created it yet. So go texture picked. Okay, so I'm getting some error. That's weird. Oh, oops. Alright, so now it's in the array. Let's define when you click it. So we could go def input, and we can pass in self, which will let us access the block, and key. So let's make voxels, which is our array, global. So we could go global voxels, and then we could go if self dot hovered. Then we can go, if it's hovered, then we can go if the key, so if key is equal to the, is equal to the left mouse, so left mouse down, then we'll destroy it. So to do this, it's actually more complicated because we need to find the index that's in the voxels array and get rid of it. But since 2 blocks can't be in one position, it actually isn't too hard. All we have to do is go index, actually no, we forgot something. We need to play our block breaking sound. So block break dot play. Okay, so the next thing that we're going to need to do is set the index to voxels dot index. This is finding the index in the array based on some JSON. So the JSON is going to be the exact same thing that we defined over here, except instead of texture picked, it's going to be self dot local texture number. So you could get the exact thing. Local texture number. Okay, so we can indent this properly because Python's all picky about that. And yeah, so I don't know why this is white, but whatever. Anyways, so that's if you remove it. Actually, I forgot something. Not totally, because you have to delete this from the actual array, which is voxels and the index. index. I'm pretty sure that just imported something. Yep. Alright. So we're going to delete this. We also want to remove it itself. So we could go destroy like we do in Phaser. But this is a function, so we could go self, which is the block itself. So the next thing that we need to do is detect for not just pushing down the left mouse, you need to detect for the right mouse, which will make a new one. So we'll go elif key is equal to right mouse down. Okay, so we can play the sound. Block make dot play. Okay, and then I don't know why I'm getting that. Block make. Oh, I missed something. Probably should have done that. Block make. Okay. So now we're going to play the sound, and instead of looking for the index, because we don't need to, we can just append it. We can go if the texture picked is equal to 1. Then we'll set the voxel to make a new voxel, so voxel of, this is what I need to pass in. So we'll go position equals self dot position okay, plus mouse dot normal. Okay, so that's going to be our position, and then for the texture, since it's 1, we could go grass texture. So we just have to repeat that, except yeah. So we could copy and paste this. 1, 2, 3, 4. 1, 2, 3, 4. So now you have grass, stone, brick, and dirt. Okay, so if all its conditions, we are done with the voxel class, which is good because that's probably the most complicated class in the whole thing. Now, let's make a class called sky. The rest of these are pretty simple. This is going to extend entity. So for this, we need to go, once again, make an init function. So def init. Once again, get rid of this stuff. And I don't actually think we need to pass in anything. So we'll just leave that. And instead of parent equals camera, we'll go parent equals camera dot UI. Okay. And model. Oh wait. Parent equals scene, sorry, not camera dot UI. Parent equals scene. Okay. And model is equal to a sphere because our world is a sphere. Okay. And then we need the texture to be the sky texture. And we need the scale to be 150. And we need double-sided so that it will actually link between both sides of the sphere. So we could go double-sided is equal to true. Okay, so now we're going to define another function. Another class called a hand. So, class hand. Now this is going to be used for like what I was just talking about, where we have that hand that goes hand active and hand passive. This is so that it can move forward when you're clicking on it, and then when you're not, it will move back. and when it moves back is passive, and when it's moving forward is active. So we can make hand extend entity, just like this guy, and let's define an init function again, and delete this stuff. And this time, I don't really think we need to pass in anything. So let's go parent is equal to the camera dot UI. Okay, and the model is going to be equal to the assets slash arm. Okay, and the texture is going to be that arm texture that we did. So texture is equal to that arm texture, and the scale is going to be equal to 0.2 because it's going to be pretty big, and the rotation, so we can move it a bit, is rotation is going to be equal to vec, which is a type of angle, vec 3, and we can go 150, -10, and 0. This will tilt it a bit. And then you can add the position. So position, this time, since it's 2D, we'll go vec 2. Okay, and then we could go 1, -0.6. Okay, so now we need that active and passive stuff that I was talking about. So we'll just go active self. Okay, and we need to set self.position is equal to vec2. Forgot some stuff. Okay, vec2, and what we're going to pass in is 0.9 and -0.5. Okay, and then we need, that's all we need for the active class. Let's set the passive class. So passive is equal to, the position is actually the exact same of what it was before. So you can just go like this. Except this time, since it would treat position like a local variable, you need to go self.position. Okay, so that's it for the hand class. And the last thing, we need 2 more classes. One is going to be the underlay, which is actually this for the hotbar. So we'll go def inventory. Underlay. This is again a simple class. This needs to extend entity. Okay. And not def. Class. Alright. So I need to make an init function, so we'll go def init. Once again, remove this. Okay. And this is actually one of the most simplest ones, because this is going to be parent of camera.ui. And this is going to be model of quad, which means it's a 2D image. So quad. Okay. And then the scale is equal to 0.20. So this is scale X, and scale Y is 0.05. Okay. And the position of this is going to be equal to a vec2, and it's going to be 0 and -0.465. Okay, and the color is going to be equal to color.rgba. Okay, and we'll go 0, 0, and 0.75, and 100. This will give it a slight transparent look. And the texture is gonna equal load texture. This does not have to be global because it's only gonna be used by this. So you could just do it like this. So assets in inventory underlay. Underlay dot png. Okay. Now that's all we need for the underlay. And the last class is the inventory. So we'll go inventory, it extends entity, pretty much the exact same thing as everything. And then we're going to need def init, except instead of leaving this blank, we're going to need to pass some stuff in, like texture, and position, and letter, which is we're going to use to like 1, 2, and 3, and 4. And this init stuff, once again, can be blank, and we'll set the parent to equal camera.ui. And the model is once again a quad because it is a 2D image. And the scale of this inventory item is going to equal, hold on, 0.20. Yeah, 0.20. And let's go 0.05. Okay. So then the position is going to equal, position is equal to vec2. Okay. This will be 0 and negative 0.465. Okay. And the color is, oh, I totally messed up. The scale, pretty much everything from down there is wrong. So I was looking at the wrong class. The scale is, actually no. Yeah, so the model's right, but we need 0.04 and 0.04. I got the scale wrong, and I also got the positioning wrong. So the position is, of course, equal to position. I was looking at the underlay class. And then the color is, we don't actually need a color, so let's take that out. But what we do need is the texture. So the texture is equal to the texture. Okay, so now we need to detect input. Fix the typo. So we could go def input is, the input is self, and key. Okay. And we're going to have to detect if this key is equal to, wait a minute. That's weird. Huh. That might have been a problem. What? I don't think this is right. Let me look at my old Minecraft one. That is right. I've never seen that in Python before. Anyway, so we're going to set this to that. You can just copy that down. If the key is equal to the self.letter, then we can go the self.scale is equal to 0.05. Else, the scale, self.scale, is equal to 3.4. This is that it'll do a little like pop animation when you press it. And of course, the update function already takes care of setting the variable, so that's all we really need. So now we're going to work on the last couple of things, which is going to detect the loading. It's going to detect loading a file, and it's going to create our new world. So no more defining classes and functions. This is the main game logic. So index, if index and list is equal to the system sys.argv. That's arguments that are passed in. And if it is equal to 1, this is list 2, which would be the file name. So then, if it is, then it will, if it's in the list, then it'll load it from the file. If there's no argument passed, and if there's no other one, then it'll just create a new world. So else, nothing. So let's start populating this, which is getting the file data. So you could go data equals open. Okay. Open sys.argv. Okay. argv sys.argv, and then we'll go 1. argv1, and then I need quotes, and it's going to be r plus, okay, which will give us permissions, .read. Okay, and then the other thing we need to do is use the Json function to convert the JSON, as in file, to a Python dictionary, which Python can read. So we can call this data Python list is equal to JSON.loadS, as in load string, and that string is going to be the data. Okay, so we have the data Python list, and so now we need to loop through everything in that big array, creating each voxel. So we can go for I in range. This is what I really appreciate about Python, is that they have a range function. So you don't have to go for var I plus plus, I less than whatever. But we could go for I in range, and then the length of the data Python list. Then, okay, and then we could detect if that element, which is data Python list I, if that I is equal to, if that texture is equal to 1, then I'll set the texture picked so that the class will read it, because the class references to texture picked. So get texture picked equals 1. And then, actually no, there's a shortcut that we can do. Hopefully this will work. I don't doubt that it won't work, but we could set the texture picked to, wait, no, whatever. I'll just do it the long way. Texture picked is equal to 1, and we need to create a new voxel. So voxel is equal to voxel, which is the position is equal to data Python list I, okay, and x, okay, and then we'll go y, so data Python list I, y, and then we needed z position, so we could go data Python list I, z. Z. Okay. Z, and then we need to set this texture. So texture is equal to the grass texture. Okay, so now I have it for grass. We're basically gonna repeat this like what we did in the update function. So we can go if else, wait, no, wait, what? I need this. Okay, and then if it's 2, then set the texture pick to 2, and set, not grass, but grass texture. And then this needs to be stone texture. Okay, and once again, we're going to copy and paste that. So we can go here, paste. If it's 3, then it'll set this to brick texture. Oops. Yep, brick texture. Okay. And one more. So then finally we could go 4, which is 4. And that is dirt texture. Okay, so that big if then statement is done. Now we need to print a little message. So to do this, we're going to use a built-in function in Ursina called print on screen. So we could go print on screen. Print on screen. Loaded world from join with the file name that they passed in. So it's going to be sys.argv1. Okay. Perfect. And now we can set that to position of 0, 0. Okay. And you can set the origin to, let's go 0, 0. And the scale is going to equal to 2. Okay, so now we're going to set the texture back to 1. So now when they place it after it finished creating, it'll set it to the grass, which is the default texture. Okay, and now we can go else. Actually, we already have that. Okay, and else is going to go for Z in range, which is looping through creating a Z position, 20. So it'll be a 20 by 20. And then for X in range, 20. So 20 by 20. And then it'll create a voxel, which is voxel is equal to voxel. So this is if they didn't pass in anything, and it's creating a new world. Position is equal to X, 0, Z. Okay. So now we have the position. The last thing that we need is to do everything. Well, not really do everything. Do a couple lines of code. First is initializing the first person controller. So it calls player equals first person controller. Okay. And the next thing that we're going to do is create a sky. So sky equals sky. And then we need to make a hand. So hand equals hand. Hand equals capital hand. Okay. Because that's what our class name is called. And then we need to make the inventory underlay. So underlay is equal to underlay. Okay. So I make sure there's no, yep, I knew it. That's Visual Studio Code importing random classes. So now we have our underlay, and what we need to do now is do those inventory slots. So inv1 is equal to inventory, and we're going to pass in load texture, and this is going to be assets slash grass block inventory. Okay. .png. Alright. So that's the texture. And now we need the position, which is going to be a vec2. And it's going to be negative 0.073. Okay. And then the second argument for vec2 is equal to negative 0.465. Okay. And we're going to make this a string of 1. So when you press 1, that's the key. So now I'm going to copy this for all 4 slots. So Control C, or Command C, as I'm using. 2, 3, 4. So then we'll change the numbers. 2, 3, 4. 2, 3, 4. Change these numbers. 2, 3, 4. Change these, which is stone, brick, and dirt. Okay. And the positions are all going to be different. So the second position is going to be, 0.025. 1 minute. We have 73 and 0.025. Yep, and then the third one is equal to 0.025, so except it's not negative, so 0.025, and then, yeah. So the last 2 functions that we're going to need is the exporting function. So we'll just go export as a comment, and then we'll define an export function. So export, this is actually a pretty short function. We'll get the JSON string, which is converting the Python dictionary, json.dumps of voxels, because that's the Python dictionary. And the number is going to be a random number from range 1 to 100, so 100. Let's see, okay. And the file is going to equal to open, which will actually create a new one because it doesn't exist, world plus string number, okay, join with .json. Give it permissions to write data to it. Okay, and we're going to need to say another message, so we'll just copy and paste this, and we'll say exported world 2, and then this time it's going to be actually here, world plus string, the number, world whatever .json. Okay, so then we're going to need to write that JSON string to the file, so we could go f.write, JSON string. Okay. And the last 4 lines of code. We're finally there, which is defining an input, which is when you press a key. Define input on key. Okay. And then if the key is equal to E, export. And you might be thinking, oh, that's not 4 lines of code. That's because there's one more, which is the all-important app.run. So hopefully we don't encounter any errors, but let's try this out. So Python 3 game.py. Oh, we have to save it. I was kind of panicking. There we go. Oh. I forgot something. So the inventory letter, that's weird. Inventory. Oh. Self.letter. Wait, that's correct. That is correct. So the inventory might be missing something. Self texture position letter. Oh, I forgot something. Self.letter is equal to letter. I forgot to make that global. There, now we should encounter no errors. There. So now you see the hand move. But for some reason the inventory is not showing. So I'm going to solve that. Alright, so I figured out the bug, and apparently it was because quad and scale were mixed up on the underlayer class. That's why that wasn't showing. And the indents were wrong on this class. So after changing a couple of indents and stuff, your class should now look like this. So pause the video to copy this down. And then here's the underlay class. Anyways, let's take a look at our finished game. So we're going to start with passing nothing. And once again, you have sound effects like this here. Awesome. And we can save our world. And oh. I also have another one, but this is simple because I did RV, not argv. Okay, let's try that again. There you go. There's our stone structure. So these are some errors I had to solve. You have to solve RV to argv. You probably noticed that. And you have to change your indents. So, yeah. That's what I really like about JavaScript. It is not based on indents. Anyways, so, yeah, we're done. I'm VBS Office, and I'll see you next time. Bye.